Section 6, Unit 4, Indexing and Rotary Table Operations. Introduction. A rotary axis provides circular motion and positioning to a milling machine. Indexing is positioning a workpiece at different angular positions using a rotary motion. Rotary tables, indexing fixtures, and dividing heads are useful when milling multiple angles on a workpiece, locating holes and circular patterns, positioning to machine features angularly spaced on workpieces, milling radii, milling circles, and milling arcs. And here's some pictures of a workpiece with features machined using rotary tables and indexing heads. Parts of a rotary table: heavy base, T-slotted table mounted on bearings for work or holding work, degree graduations, hand wheel for turning table via gear reduction for precision. Many rotary tables have a center hole through the work table, sometimes with a Morse taper. There's a picture of one. Angled graduations are over here on the sides of the rotor. You got T-slots, you got an angle block, and a hand crank, and then there's your base. Alright, rotary table setup. Rotary table is mounted to the mill table with a T-slot hardware. Rotary table center is aligned with the machine spindle. Center line and zeros are set. Work is loosely attached to the rotary table in the same manner as with other milling devices. Work is aligned with the center of the rotary table and or at desired angle and secured. And then the rotary table setup for milling a partial radius. Rotary table setup for drilling equally spaced holes in a circular pattern. Aligning a straight edge of a workpiece on the rotary table. And aligning a workpiece with a center hole on the rotary table using a test indicator. Rotary table operations: angular positioning and milling, or for milling and drilling. So move one axis the distance equal to the radius when drilling a bolt circle. Then use the rotary table graduations to position the workpiece at the desired angular locations. Angular positioning for milling and drilling. A rotary table can be used to position a workpiece at desired angular locations for milling features such as flats or slots. Alright. Compensating for tool when milling an external circular feature. So if you got a 3-inch diameter external feature and a 1-inch diameter end mill, of course you got 1.5 feature radius and a 1/2 inch end mill radius. So you add those together and you got 2-inch total table movement from the center line. Alright, compensating for tool when milling an internal feature. So you got a 3-inch diameter internal feature with a 1-inch diameter end mill. So of course you got a 1/2 inch end mill radius and a 1.5 feature radius. So you'll subtract the 1.5 inch from the 1.5, so you'll actually have 1-inch table movement. And no tool compensation is needed when a circular slot is dimensional to its center line and machined with the tool equal to its slot width. So if you got a 1-inch wide circular slot all the way around the part, a 3-inch diameter here, and a 1-inch diameter end mill, so you move over 1.5 total table movement. Collet blocks allow simple manual angular part positioning. Setup is held in a milling vise and incrementally rotated manually. Only available in certain shapes, typically a square and hex, and major parts are collet block body, collet nut, and collet. And here's a picture of a square and hexagonal collet block. Touching off the top of the workpiece held in a square collet block, note the work stop against the block that will be used for repositioning. Milling the first flat of a square. Milling the second flat of a square after rotating the collet block in the vise. Completed milling square. The indexing fixture serves as a rotary axis for basic direct indexing, fixed part positioning. Usually available with an indexable plate capable of divisions that are divisible by 24, although 18, 30, and 36 may be available. Accept either collets, centers, or chucks for work mounting. And setup, headstock indexable head must be aligned with the table axis. Tailstock, if used, must be aligned with the indexing fixture, and work must be mounted. An indexing fixture that uses collets to hold workpieces, the lever is used to unlock, rotate, and relock the spindle in position. Hexagonal flax milled using an indexing fixture. The indexing head serves as a rotary axis for fixed part positioning. Major parts are gearbox, spindle, direct index plate, simple index plate, sector arm, simple index crank. The setup, headstock indexing head must be aligned with the table axis. Tailstock, if used, must be aligned with the indexing head. Work must be mounted, and correct plate must be selected for divisions required. Direct indexing, number of notches in the plate must be equally divisible by the number of divisions needed, so notches per divisions equals notches index plane over or divided by division required. Simple indexing, many more numbers of divisions possible than the direct indexing. The amount of the crank turn 40 turns results in 1 turn of the spindle. So 40 divided by D equals T, where T is the number of turns the crank handle and D is the number of desired divisions. The parts of an indexing head, or indexing or dividing head, a 3-jaw chuck is mounted on the spindle of this model. So you got your direct indexing holes, your direct indexing plunger pin, sector arms, indexing crank plunger pin, indexing crank, and sector arm lock screw, indexing plate stop, and your spindle nose. An indicator can be used to align the dividing head. A simple indexing plate, note that each circle has a different number of equally spaced holes. Adjusting sector arms to obtain the correct spacing between holes. Rotate the sector arms to reset the hole spacing after positioning the crank.